Trapezoids are a special type of quadrilateral. So what makes a quadrilateral a trapezoid? Well, one of the characteristics is that it must be convex, just like the kite, no dents going inside, no cave-ins. Additionally, it has only one pair of parallel sides. For example, if you look down here on the lower right, and let me get my pen, that particular quadrilateral on the lower right has two pairs of parallel sides. So two pairs of parallel sides. And I'll just do the shorthand symbol for parallel. You might want to spell it out. That looks like 11. Another thing we know about trapezoids are that consecutive angles who share the same leg are always supplementary. So supplementary means they add to 180. If you look at this trapezoid here, you've got 90 degrees, and I've got 90 degrees down here. That adds to 180. It's also true for these other trapezoids. If you get off of they share the same leg, not the base, but the leg. Those will always add to 180. Now, the mid segment, and I should draw one in here. I don't have one on the note. It is kind of like the mid segment of a triangle. It connects the midpoints that are on the two legs. So it connects the two midpoints. And a cool thing about mid-segments on trapezoids is that they are equal to half of the sum of the lengths of the bases. So I've been using some words, bases and legs, so let's talk about those words. Bases are the parallel sides. So oftentimes we normally put a trapezoid on a base. So this could be base 1 and that could be base 2. Same thing here. It doesn't really matter if you put base 1 and base 2, one on top or one on the bottom, but they're just two different bases. On this bottom trapezoid, the bases are actually vertical. So there they are. The bases are basically the two parallel sides. Now we also have a name for the non-parallel sides. Those are called the legs. Base angles are two consecutive angles whose common, so the legs are, let me go over this, the legs are like here are some legs, there are the legs. The legs are never going to be parallel on a trapezoid. The base angles are the angles that share a base. So they're two consecutive angles whose common side is the base. So this would be a base angle here, there's another base angle there. And then I also have on top on this one, base angles here and base angles here. Now in this particular trapezoid in the center, you probably noticed that the base angles are congruent and so are the legs. That is called an isosceles trapezoid. So it has congruent legs and congruent base angles. Here you can see the base angles here are not necessarily congruent. So this angle does not equal the 90 degrees, and this angle on the top left does not equal the 90. Now, one other thing we know about the trapezoid midsegment is it connects the midpoints of both legs. So now we'll talk about some theorems about the very special trapezoid. Oh, by the way, this one has no parallel sides, this counterexample here, and that is why that is not a trapezoid. It sort of looks like one, but not quite. Okay, now some theorems about the isosceles trapezoids. If a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. So that means angle A here and angle D, angle B and angle C. If a trapezoid has one pair of congruent base angles, then the trapezoid is isosceles. So this is just going backwards from the theorem on top here. So the first theorem says if it's isosceles, then the base angles are congruent. Then the second one right here says if the base angles are congruent, just one set is all you need, then it's an isosceles trapezoid. So here they tell me angle A and angle D are congruent. That is enough for me to conclude that this is an isosceles trapezoid. One other special thing about isosceles trapezoids is that their diagonals are also congruent. And you can see basically if we say if ABCD is isosceles, if and only if AC, the length of AC, is equal to the length of BD. So let's do some examples where we're going to be dealing with some midsegments and some other properties of trapezoids. We're going to find the length of QR. So we have a base here on the bottom and a base on the top, and the midsegment is 22. So I can say 22 equals half of the sum of the 30 plus the length of this QR. It's kind of like taking the average of the top base and the bottom base to get the middle. When I go ahead and write the equation here, I realize, okay, that 2 is bothering me, so I'm going to multiply both sides by 2. What that means is I can simplify that 2 cancels out. It becomes 1. 2 divided by 2 is 1. So I have 2 times 22 equals 30 plus the length QR. 44 equals 30 plus QR. I don't want the 30 here. I want to isolate my unknown, which is QR. So I subtract 30 from both sides, and I get the answer that QR is 14. And that does make sense. If you go back here, put a 14. 14 plus 30 is 44. Aha, 22 is half of 44. Now this one's a little bit trickier. I'm going to find the length of the midsegment here, but there are no numbers to start with. Now we just have a bunch of variables. Well, I'm still going to use the same principle. This midsegment is half of the sum of the top base and the bottom base. So n plus 6 is the midsegment, and it equals half, which I'm showing by the divide by 2 here, n plus 3n minus 5. Now, if I want to solve that, I can combine my like terms. So I say n plus 6 equals 4n minus 2 divided by 2. The 4n came from n plus 3n. The minus 2 comes from 3 and negative 5. But I don't like having that divide by 2, so I multiply both sides by 2 so that can simplify. So now I have 2 times n plus 6 equals 4n minus 2. Applying the distributive property, I have 2 n's. There's 2n, and I have 2 6's, which is 12. So 2n plus 12 equals 4n minus 2, and then I go ahead and add 2 to both sides to kind of get that 4n by itself, and this 2n is still on the other side, so I subtract 2n from both sides to get 14 equals 2n. I'm looking for n for now, divide by 2, and I get n is 7. Well, they want the length of the midsegment, so I need to go back in here and substitute in. And I get n plus 6. So 7 plus 6 is 13. The length of the midsegment is 13. In example 3, I'm trying to find the measure of each numbered angle. So I'm going to use a property that adjacent angles on a leg, not a base. So angle 1 here, right? And angle 2, in fact, let me highlight those. So angle 1 and angle 2, that's this angle here and this angle here, are supplementary. Supplementary means that they add up to 180 degrees. So I can say the measure of angle 1 plus 98 equals 180. Subtract 98 from both sides, and I find out that angle 1 is 82. I can do the same thing on the other set. I can say, here I'll do green, I can say that 52 and angle 2, the 52 degrees in angle 2 are also supplementary. So measure of angle 2 plus 52 is 180. Subtract 52 from both sides, and my answer is 128. So I was able to find all the 2 missing angles in the quadrilateral, even though I knew only 2 of the angles already in there. In the last example, we're going to find angle 1 and angle 2. First thing I do is I say, aha, this is how do I know this is an isosceles trapezoid? Well, first of all, I can see the congruence marks here, and then I know my parallel lines. Well, I have alternate interior angles, so I know that that's 34. Since it's alternate interior, this also creates an isosceles triangle up here, so I know that that's 34 degrees up there. Now I'm trying to find angle 1. So I say 34 plus 1, this is one triangle right here, is 180 degrees. Then I combine the 34 and 34, so I get 68 plus the measure of angle 1 equals 180. Subtract 68 from both sides, and I find out that angle 1 is 112 degrees, which is good. So angle 1 is 112 degrees right here, 112. But I'm trying to find out measure of angle 2. When I look at measure of angle 2, it's in a different triangle. It is, hold on, in this triangle right here. I know that this is 72 because these are 34. These two angles are going to be congruent. And if I know that's 72, I'm still missing this angle right here in that corner, right in here. So how could I find that? Well, it forms a linear pair with angle 1. So I can say, okay, 112 plus this mystery angle must be 180, and I just called it x. So 112 plus x equals 180. Subtract 112 from both sides. So I find out that mystery angle is 68. Now I know two of the angles in this yellow triangle. So I can say 72 plus 68 plus the measure of angle 2 must be 180. Combine my like terms, 68 and 72, then subtract 140 from both sides, and I find out the measure of angle 2 is 40 degrees.